Good afternoon. My name is Ryan Palmer. And today we've got the three-point test cross analysis. So here we have our data set. We have on the left side offspring genotype, and on the right, the number of times that they occur. And at the bottom, we have the total number, which is 5,742. So first, we have our non-recombinant and recombinant types. First, we have parental genotypes, and these are identifiable as they are the most frequently occurring genotypes, um, due to the fact that it's more common for these to not recombine than they are to recombine. And then for recombinant, we have our single crossovers as well as our double crossovers. Double crossovers are easily identifiable as well. These are the least frequent occurrences due to the fact that they contain two recombination events per, and it's already rare enough that recombinations happen. And of course, the remaining will be your single crossovers. Now, looking at double crossovers, we can determine the gene order. So looking at the crossovers, double crossovers, we notice that the A gene is the only one that crosses over. Therefore, the A gene must be in the middle. So we have gene order BAC. It could also be CAB. Map distances. We have B to A. So we must identify all recombinants with a BA interval. So we've identified the four. There are two that have A to B exclusively, and then you have two being the double crossovers, considering they contain two recombination events. They do contain the B to A recombinations. We find the sum to be 1060. In the equation, we have our total B to A recombinants over the total number of resulting genotypes, and then multiply that by 100. So we find 1060 divided by the total 5,742. Times that by 100, we get 18.46. Percentage-wise, this can be the um, recombination frequency, but it's also the distance between the B and A genotype in the sense of centimorgans, which is 18.46. And for each centimorgan, there is a 1% chance that these two genes will recombine. And now we have A to C. Same idea. Find all recombinants at the A to C interval to include your double crosses, which also contain an A to C recombination. We get the sum to be 2,220. Same idea for the equation. We have the total A to C recombinations over the total number of genotypes multiplied by 100. And we find that we get 38.66. So the distance between A to C would be 38.66 centimorgans, and there is a 38.66% chance that there will be a recombinant event between genes A and C. Chromosome map. So from the first slide, we have our gene order BAC, and then we have the distances in centimorgans between B and A and C. So first, we can identify our B gene, place that on our chromosome. Now we have our distance of 18.46 centimorgans, and then we'll have our A gene. Again, we got our 38.66 centimorgan distance, and we can now plot the C gene. So roughly, this is what the chromosome would look like. Double crossovers, expected versus observed. Expected double crossovers. The equation, we have the recombination frequency of B to A multiplied the recombination frequency of A to C times the total number of genotypes. So we find our B to A to be 0.1846, and we have our A to C as 0.3866 times the total number, 5,742. And we expect to have about 409.82 double crossovers. So we're expecting roughly 410. Now observed, We had two double crossovers. We find the sum of those is 240. So we expected 410 roughly. We observed 240. Why is that? So we'll find our coefficient of coincidence, or COC. Simply put, we have our observed double crossovers over our expected, 240 divided by 409.82. We have a 0.586. Using this COC, we can now find our interference. So interference is simply 1 minus 0.586 being our coefficient of coincidence. We've got 0.414 resulting. Multiply that by 100, and now we have our interference percentage. So what does this tell us? When it comes to double crossovers, with each event of double crossover, there's now a less likely occurrence of another double crossover occurring nearby, meaning that 41.4% of the expected double crossovers did not occur because the 240 that did occur lessened the likelihood that the other double crossovers would have occurred. Thank you very much.